Assalamualaikum warahmatullahi wabarakatuh, and good afternoon. Last week we already discussed about the subnetting and also VLSM. So today we're going to continue. This will be the last part for the network layer chapter. So we will go to the network layer function. So there are three functions for the network layer. So the first thing is the path determination. So the network layer must determine the route or path taken by packets as they flow from a sender to receiver. So the algorithm that calculate this path are referred to as routing algorithm that we're going to discuss later in this chapter. The second function is switching. When a packet arrives at the input to a router, the router must move it to the appropriate output links. So a router usually have a 2 or 3 output. So the router need to know which output link that need to be sent for the arriving packet. And the third function is the call setup. Recall that in our study in TCP, a three-way handshake was required before data actually flow from sender to receiver. So in an analog manner, some network layer architecture require the router along the chosen path from source to destination handshake with each other in order to set up state before data actually begin to flow. So in the network layer, this process is referred to a call setup. So let's look into the network service models. There are two types of service model in this layer. First is datagram and second is virtual circuit. So in this slide, we will discuss on the virtual circuit, or we call it VC. So a virtual packet network behaves much like a telephone network, which use real circuit as opposed to virtual circuit. So there are three identifiable phases in a virtual circuit. So the first is the VC setup, virtual circuit setup. So during the setup phase, the sender contact the network layer, specify the receive address and wait for the network to set up the VC. So the network layer determines the path between sender and receiver, that is the series of link and packet switch through which all packet of the VC will travel. So this typically involve updating table in each of the packet switch in the path. So during the VC setup, the network layer may also reserve resource, for example bandwidth, along the path of VC. The second is the data transfer. So once the VC has been established, the data can begin to flow along the VC. And lastly is the VC teardown. So this is initiated when the sender or receiver inform the network layer of its desire to terminate the VC. So the network layer will then typically inform the end system on the other side of the network of the call termination and update the table in each of the packet switch on the path to indicate that the VC no longer exists. However, with datagram network layer, each time an end system wants to send a packet, it stamps the packet with the address of the destination end system and then pops the packet into the network. This is done without any VC setup. Means there will be no setup for the link between one host to another host, a sender or receiver. Instead, packet switch route a packet toward its destination by examining the packet destination address, indexing a routing table with the destination address and forwarding the packet in the direction of the destination. So because the routing table can be modified at any time, a series of packets sent from one end system to another may follow different paths to the network and may arrive out of order. So the internet uses a datagram network layer. So this is an example, the difference between datagram and virtual circuit. So this figure here is the virtual circuit VC service model. So the first thing that the sender and the receiver need to do is to establish connection. So the sender need to initiate the call and the receiver need to accept the call, and this means that the call is connected, the line is connected, and you can see the route of the data flow will be the same until the VC is terminated. So for example, it's already connected with these three router, means that from one packet to the last packet will flow in the same link. However, in this figure here, which is the datagram service model, if you look at this, it will send the data without any VC setup or established connection. So the send data will flow in any direction. So we will not have a one-way connection. It might go to this router or this router. So it depends on the algorithm. And the receiving data will not be synchronized or in sequence. So this need to be rearranged. The data need to be arranged in the transport layer. So we're going to look in the routing principle. So in order to transfer packet from sending host to the destination host, the network layer must determine the path or route that the packet are to follow. So whether the network layer provides a datagram service or virtual circuit service, VC service, the network layer must nonetheless determine the path for a packet. This is the job of the network layer routing protocol. So at the heart of any routing protocol is the algorithm, or we call it the routing algorithm, that determines the path for a packet. So the purpose of a routing algorithm is simple, which is to find a good path from source to destination. Typically, a good path is one that has the less cost or the shortest path. Thus, this is an example or abstract model of a network. The number here is the cost. So in this example, we consider the simplest algorithm where this cost is representing the number of router. So for example, from router A to router C, it is connected to 5 router. So we know that the algorithm is the function of the routing algorithm is to find the shortest path. For example, we want to send a packet from A to F. So we need to determine which path is the shortest. So in this example, we know that the shortest path is from A, D, E, F because it has the less cost, which is 1, 1, 2. So the total is 4. So if you look at other connection, for example ACF, the cost is 10, which is 5 plus 5. So it means that it has a longer path compared to this one. So it means that the packet will go from A, D, E, and F to F. So in the routing algorithm, we will discuss two types of this algorithm. The first is the link state algorithm, and the second is the distance vector algorithm. So the link state algorithm is also known as the global routing algorithm, while the distance vector algorithm is also known as the decentralized routing algorithm. So let's look into the link state algorithm first. So link state routing algorithm in contrast require that all routers know about the path reachable by all other routers in a network. So it means that if there's 50 router in one network, it means that all router knows each routing table for all router in one network. So link state information is flooded throughout the link state domain, an area in OSPF or ISIS. So OSPF or ISIS is the routing algorithm, the name of the routing algorithm. So to ensure all router possess a synchronized copy of the area link state database. So from this common database, each router constructs its own relative shortest path tree with itself as the root for all known router. So it means that has all the router has the map for all routing data or database in a network. So compared to distant vector routing algorithm, distant vector routing is named because it involves two factors: the distance or metric of a destination and the vector or direction to take to get there. So routing information is only exchanged between directly connected neighbors. This means a router knows from which neighbor a route was learned, but it does not know whether that neighbor learned the route, and a router can see beyond its own neighbor. So compared to link state, the router knows every router database in the network. However, in distant vector, router only knows the neighboring router information only. So the distant vector algorithm we will now present is decentralized and does not use such global information. Indeed, the only information a node will have are the cost of the link to its directly attached neighbors and information it is received from these directly attached neighbors. Let's look into the IP protocol which is used in the internet. So the internet network layer provides connectionless datagram service rather than virtual circuit service. So when the network layer at the sending host receives a segment from the transport layer, it encapsulates the segment within an IP datagram, write the destination host address as well as other fields in the datagram, and send the datagram to the first router on the path toward the destination host. So in current IP protocol using IPv4 and also IPv6. So the network layer in datagram-oriented network, such as the internet, has three major components. The first is the routing protocol. So it uses routing algorithms such as OSPF, RIP, or PGF. So the second component is the routing table, which is a database that the routing algorithm has been calculated. Is stored in this routing table. And the last component is the IP protocol and ISMP protocol. IP protocol is the addressing convention and also the datagram format. And for the ICMP protocol is the for error reporting. So to assign an address to a host, so we can use two configuration. The first is the manual configuration. So the IP address is configured into the host, typically in a file by the system administrator, while the second is the Dynamic Host Configuration Protocol, DHCP. So DHCP usually is the default for all hosts or computer in the network. DHCP is sometimes referred to as plug and play. With DHCP, a DHCP server in the network, for example in the LAN, receive a DHCP request from a client, and in the case of dynamic address allocation, allocates an IP address back to the requesting client. DHCP is used extensively in LAN and in residential internet access. This is the datagram formats. In the network layer, we also need to consider the IP fragmentation and resample. So some protocol can carry big packet, whereas other protocol can only carry little packet. For example, Ethernet packet can carry no more than 1500 bytes of data, whereas packet for many wide area link can carry no more than 576 bytes. So the maximum amount of data that a link layer packet can carry is called the MTU, maximum transfer unit. So fragment needs to be reassembled before they reach the transportation layer at the destination. Indeed, both TCP and UDP are expecting to receive complete unfragmented segment from the network layer. So let's look into this example. For example, we have one large datagram with a size of 5,000 bytes. However, in this link here, it can only accept 1500 bytes. So this is the link MTU. Means that this large data need to be fragmented. So how we want to fragment the large datagram? So first we need to make a table here, for example this one, and we fragment the first pieces. In the first fragment, we can only fragment 1480 bytes of the data. So here because why we can only fragment 1480 where the link MTU is 1500, because these 20 bytes need to be used for the header. So that's why we need to minus or deduct 1500 minus 20 bytes. So that's why we get this number. So the identification is 777, offset is 0, and flag is 1. So 1 meaning that there is more fragment, 0 meaning this is the last fragment. So the second fragment still the same, 1480 byte. We need to deduct 20 byte from the link MTU. The identification is still 777 for fragmentation, and offset we need to put 1480, meaning that the data should be inserted beginning at byte 1480, because the first fragment we use 1480, so the offset is the same as the first fragment. And the flag is equal to 1, meaning there is another fragment coming. And the third fragment or the last fragment, so we need to deduct the total, which is 3980. So basically here is 4000. However, we need to deduct 20 byte for the header, so that's why we get this number, minus 1480 the first fragment, and another minus 1480 the second fragment. So that's why we get 1020 bytes. The identification is 777, and the offset, you need to add both fragment here to get this value offset. and the flag is equal to 0 because this is the last offset. The last fragment. So meaning if the datagram is larger than 4000, you need to have multiple or 4 or 5 fragment until all the data is being fragmented. So at this side, if you look at this, is basically all the fragmented data is reassembled back and send it to the receiver. So let's look into the routing in the internet, which is the intra-autonomous system. So an intra-AS autonomous system routing protocol is used to configure and maintain the routing table within an autonomous system. So autonomous system, for example, is the UTM network. It's an autonomous system. So intra-AS routing protocol are also known as interior gateway protocol. Historically, three routing protocols have been used extensively for routing within autonomous system in the internet. So the first routing protocol is the RIP, Routing Information Protocol. Second, OSPF, Open Shortest Path first. And the third is EIGRP, which is the Cisco's Priority Enhanced Interior Gateway Routing Protocol. So let's look into the RIP, Routing Information Protocol. So Routing Information Protocol was one of the earliest intra-AS internet routing protocol and is still in widespread use today. So RIP use distant vector algorithm, which if you remember back, distant vector algorithm, it's the algorithm only share information between the neighbors. So in RIP routing table are exchanged between neighbors approximately every 30 seconds using a so-called RIP response message. So the response message sent by router or host contain the sender routing table entries for up to 25 destination network within the AS. So response message are also known as RIP advertisement. So for the OSPF, Open Shortest Path first, OSPF was conceived as the successor of RIP and as such has a number of advanced features. So at its heart, however, OSPF is a link state protocol that uses flooding of link state formation. So with OSPF, a router constructs a complete topology map of the entire autonomous system. So each router has the complete map of the network system. So the router then locally run link state algorithm to determine the shortest path tree to all network with itself as the root nodes. So with OSPF, a router periodically broadcasts routing information to all other routers in the autonomous system, not just to its neighboring router, compared to the RIP. And lastly, the IGRP, Enhanced Interface Gateway Routing Protocol. So EIGRP is a Cisco routing protocol developed in 1997. EIGRP is a distant vector protocol similar like RIP. So several cost metrics include delay, bandwidth, reliable, and load can be used in making routing decisions, with the weight given to each of the metric being determined by the network administrator. So basically the cost for the metric can be determined by the administrator compared to RIP, which only calculate or compute 2 or 3 metrics. So let's look into the router. So router is a switching function that actually transfer of datagram from router incoming link to the appropriate outgoing link. So this is the router architecture, which consists of input ports, a switching fabric connected to a routing processor, and lastly the output port. So the input port performs several functions. It performs the physical layer functionality of terminating an incoming physical link to a router. It performs the data link layer functionality needs to interoperate with the data link layer functionality on the other side of the incoming link. It also performs a lookup and forwarding function. The switching fabric connects the router input port to the output port. This switching fabric is completely contained within the router. So it switches the packet from one input port to another desired output port. So, and the output port and output ports stores the packet that has been forwarded to it through the switching fabric, then transmit the packet on the outgoing link. So the output port thus perform the reverse data link and physical layer functionality as the input port. So that's all for today, and also the end of the chapter 4, which is the network layer. So after this, we're going to discuss the last chapter, which is the data link and physical layer. So that's all for today. See you. Thank you. Assalamualaikum.